Welcome everyone to our presentation at the Photonics Plus platform. Today, I am Alexander Telle, the CEO of ACM, the German subsidiary of Acktar. Acktar is an Israeli technology company, and we are specialized in the development and the application of ultra-black light-absorbing coatings and coated foils. There are three general applications for our products. You can use them to suppress stray light, to absorb laser power, or to create high emissivity surfaces. We are active in the wide field of photonics, and with that in most of the technical markets like industrial vision and sensors, life science, analytics, medical, lasers, semiconductors, and also space. Today, let's speak about the availability and usefulness of BRDF and TIS data, total integrated scatter data, from relevant surfaces in optical systems. Let's start talking about the why and the when to think about scattered light at all. Many of you know that scattered light can have a dramatic impact on the quality and performance of an optical system. If you address this challenge, for example, with a deep black absorber coatings, you can easily positively influence the image quality, the contrast, or even the sensitivity in the system. And this at the level of the hardware and not at the later stage in the image processing. Taking these considerations into account as early as possible in the development process helps to clarify the necessity of scattered light suppression measures. In this way, it is possible to increase performance or to reduce the complexity of the optical setup with relatively little effort. But also later in the product life cycle, integration of measures for stray light optimization can provide benefits. For example, higher or more reliable quality of the system. I believe there are at least two ways to approach stray light optimization: trial and error testing or simulation and analysis. Although we have a lot of experience with trial and error projects, believe me, and I believe also you have, I would like to advertise stray light simulation and analysis today. It's an important tool in the development of high-performance optical instruments, but the simulation can only be as good as the data that is put in. BRDF is used to describe the scattering behavior of optical surfaces. How it works is described in the image here on the left. And this is what we have measured for all our products in the past months to give you the best possible fundament for your simulations. The data, which is now freely available to every interested optical designer, is on a completely new level in its extent. It provides an unprecedented basis for the development and simulation of optical systems. And we are fully transparent with the performance of our products and show what is really relevant for the optical design and not only what looks good. So we have had a special focus on larger angles of incidence, for example, as this is where the most changes for reflectance behavior happens. And here on the left, you see a very nice visualization of the BRDF performance of one of our direct coatings, Magic Black, just as an example of what is included in our database. Here you can see the technical parameters of our available data. You can see here that we have measured quite a lot angle of incidences. So 10 degrees, 30 degrees, 50, 70, and 80 degrees incoming light on the probe. And we have measured in two different wavelength ranges indivisible with a white light source, and in the near infrared with a monochrome 1.55 micrometers laser source. We have also measured the TIS values of our coatings in the visible and the near infrared. We are currently working with all major optical design and scattered light simulation software providers to integrate our data into their material databases. For example, with companies like CMAX, for softwares with Reject1, Synopsys softwares, Fred, and so on. But you can also get this data directly from us right away. Just ask us. That's it for the BRDF database. And now I want to give you a summary of the advantages of our ultra black coatings. What is special about our technology is that the coatings are working in an extremely broad wavelength range, in the UV, in the visible, but also far into the infrared. They are temperature resistant and durable, and we can apply them to most materials. There are really only two restrictions. The material must be vacuum compatible and temperature resistant to roughly 120 degrees Celsius. So we can apply the coatings to almost every metal, but also to glass, ceramics, silicon, and also to temperature resistant plastics. Our technology, our coatings are inorganic, and they are qualified for demanding applications like for space, for ultra high vacuum, but also for clean room and semiconductor environments. What is special and really helpful in different optical applications is that we are able to conformably coat sharp edges and complex geometries. And that helps, for example, with baffles, vanes, and apertures, even pinhole apertures, where we are able to apply the coating to. The coating is relatively thin, speaking about nominal 5 micrometers for the visible and near infrared wavelength range coating thickness. And it's RoHS and REACH compliant, and this won't change in the near future. In these SEM images here on the left, you can see how our coatings work. We create a surface morphology from a composition of metal-metal oxide structures that lead to a high specific surface area, and with that to a sliding refractive index from the medium air, for example, into the coating. So how can you make use of our technology? We have two options for you. One we call direct coating, where the coating is applied directly to a discrete component. It's done in a proprietary vacuum deposition process at our premises. And a typical example is shown here in the picture, a lens housing with a quite complex geometry. The second option is the use of our coated foils. They wear the same coating on a thin film substrate. Typically, an adhesive backing is added, and we supply you with sheets or customized pre-cuts and die cuts. Very easy and convenient to use. Also, the foils are available with space-grade materials, for example, with polyamide or Kapton substrate, optional with VDA layers on one or both sides, and Acktar's black coating on one side. That can be a typical application as a single layer or multi-layer insulation. As already said in the beginning, we are active in various markets and applications. Here is just a partial overview. Wherever light is generated, shaped, and detected, there's always light that disturbs and is undesirable. And Acktar black coatings suppress and absorb this scattered light, and with that enhance the performance of the optical systems. And with that, I end my presentation, but not without asking you to contact us by phone, email, or LinkedIn, or here on the Photonics Plus platform. Looking forward to it. Give us your straylight problem, and we want to solve it. Thank you very much.